Hello, everyone. Welcome to this exciting presentation on 10th Standard Algebra Explained Easy. Today, we'll explore super fast formula tricks, focusing on shortcuts for calculating a plus b2 and a b2. I'll guide you through these concepts in a simple and engaging way, helping you master these algebraic formulas quickly. So get ready to boost your math skills with some easy and effective tricks. Let's talk about a quick calculation trick for exams that can really save you time. Instead of doing long multiplication, which can be time-consuming and prone to mistakes, this shortcut helps you get the answer faster. It not only speeds up your calculations, but also improves your accuracy, which is crucial during exams. So, why should you learn this shortcut? Because it makes solving problems more efficient, giving you more time to check your work or tackle other questions. Incorporating these quick methods into your practice can boost your confidence and overall performance. Let's take a closer look at this important algebraic identity, a plus b2. To understand it thoroughly, we'll break it down step by step. First, we square the first number, which is a. This gives us a 2. Next, we square the second number, b, resulting in b2. Then we multiply the two numbers together and b and double that product to account for both cross terms. That gives us 2ob. Finally, we combine all these results to get the expanded form, a 2 plus 2ob plus b2. This formula is fundamental because it helps us understand how to expand binomials quickly and accurately, which is a key concept in algebra and many other areas of mathematics. Let's walk through this example step by step. We have 12 plus 8, 2, which is a perfect case to see how the expansion works. First, notice I break it down into 3 parts, 12 squared, twice the product of 12 and 8 squared. So 122 equals 144. This is straightforward because 12 times 12 is 144. Next, we look at 2 times 12 times 8, which equals 192. This middle term captures the interaction between the two numbers when we expand the square. Finally, 82 equals 64. Adding all these up, 144 plus 192 plus 64 gives us a total of 400. Now let's connect this to the general pattern. When you see something like a plus b2, it always expands to a 2 plus 2ob plus b2. This example helps us understand that pattern concretely. The key point here is that the square of a sum isn't just the square of each part separately. It also includes twice the product of the two parts. This concept is fundamental because it shows up frequently in algebra and simplifies many calculations. Remember, recognizing this pattern makes working with binomials much easier. It's like a shortcut that saves time and helps us avoid mistakes. So, understanding this example thoroughly sets the stage for mastering more complex algebraic expressions. All right, let's look at the expansion of a b squared. The formula is a b2, which equals a 2 minus 2ob plus b2. Now, what does this mean in practical terms? Well, when you square a binomial like this, you take the square of the first term, then subtract twice the product of both terms, and finally add the square of the second term. This shortcut is really handy because it saves us from multiplying everything out step by step. Think of it as a quick way to expand these squared binomials. Just remember, first number squared minus double the product plus the second number squared. It's a fundamental concept that ties into our overall theme of simplifying algebraic expressions, making calculations more efficient and less prone to error. So, mastering this shortcut will definitely make your algebra work smoother and more confident. Let's look at an example. 15 minus 5 squared. When we expand this, we get 15 squared, which is 225. Then we subtract twice the product of 15 and 5, which gives us 150. We also add 5 squared, which is 25. When we combine all these parts, the result is 100. Now let's consider a more general example. A minus b squared. This formula is very useful because it helps us understand how the subtraction of two terms behaves when squared. The key point here is that it expands into 3 parts. The square of the first term minus twice the product of the two terms plus the square of the second term. Understanding this expansion is important because it connects to many algebraic concepts, such as factoring and simplifying expressions. So, grasping this pattern helps us see the structure behind more complex algebraic equations, which ties into the overall theme of mastering algebraic identities. All right, let's talk about some quick ways to remember these sign changes. When you see a plus sign, think of it as adding two obs, so it becomes plus 2 ob. Similarly, a minus sign means subtracting two obs, which gives you minus 2 ob. This might seem simple, but it's actually a really handy shortcut. Instead of trying to memorize complicated rules, you can just remember that plus equals plus 2 ob and minus equals minus 2 ob. It's a great memory trick that makes solving these problems much easier and faster. Keep this in mind as you work through similar expressions, and it'll help you stay confident and efficient. All right, let's look at these practice questions. First, we have 18 plus 2, which equals 400. When we add 18 and 2, we get 20, and squaring that gives us 400. The key idea here is that the sum inside the parentheses is then squared, so it's about understanding how to simplify the addition first before applying the square. Next, we have 25 which equals 225. Subtracting 5 from 20 gives us 15, and squaring 15 results in 225. This highlights how subtraction inside the parentheses affects the value we then square, and it's important to do the operation inside the parentheses first to simplify the calculation. Then, 11 plus 9, 2 equals 400. Adding 11 and 9 gives us 20 again, and squaring 20 yields 400. Notice how different expressions can lead to the same result when the sum inside the parentheses is the same. Finally, 30 10 2 equals 400. Subtracting 10 from 30 gives us 20, and squaring 20 results in 400 once more. This reinforces that regardless of the operation, addition or subtraction, if the result inside the parentheses is 20, squaring it will always give us 400. These questions are a great way to practice recognizing how to handle operations inside parentheses before applying the exponent. They connect back to our overall theme of understanding the order of operations and the importance of simplifying expressions correctly. Just remember, always do what's inside the parentheses first, then apply the exponent. All right, let's break down why the formula works. When we expand a binomial like a plus b squared, it actually creates 4 different multiplications. These come from multiplying each term by every other term, a times b times a, and b times. Now, the middle terms, which are a times b and b times a, combine to give us plus or minus 2 ab, depending on whether we're adding or subtracting. The key here is understanding that this simple logic, multiplying each term with every other, helps us see why the formula works so neatly. It's a straightforward process, but it reveals the symmetry and structure behind the algebra. So when you ask, why does this formula work? The answer is because of this systematic expansion and how the middle terms combine. It's all about breaking down the multiplication step by step and seeing how the parts come together to form the perfect square. Like, share, subscribe, those are the key actions I hope you'll take to stay connected. Sharing this with others helps spread these algebra tricks and makes math more accessible for everyone. And of course, subscribing ensures you won't miss out on future content. We've got more algebra tricks coming soon, so stay tuned for even more tips and strategies to make algebra easier and more fun. Thank you so much for being part of this journey. I really appreciate your time and engagement. Remember, learning algebra is a step-by-step process, and together we're making it simpler and more enjoyable. Thanks again, and see you next time.